This is a roulette wheel, a common gambling game in casinos. A ball is placed onto the wheel, and the wheel is spun until it stops. The ball falls into one of the 38 slots. There are 36 numbered slots, plus a 0 and a double 0. You win if it falls into the slot with the number you picked. Therefore, the probability of your number winning is 1 out of 38. Let's bet $1 on lucky number 13. The standard payoff is $35 if our number wins, and nothing if your number loses. Ready? Spin! So close, yet so far. Well, what would happen if you played this game over and over for a long time? Well, you would expect to win once every 38 spins, on the average at least. So you would be paid $35 every 38 spins. On the average, each spin would win $35 divided by 38, or about 92.1 cents. This is what we call the expected value. In the long run, you would expect to win 92.1 cents for each $1 bet. Now, you could play once and win $35 right away, or you could play 1,000 times and lose all $1,000. But in the long run, you would win 92.1 cents for every dollar you bet. The casino, on the other hand, wins the other 7.9 cents of every dollar. Here's a situation with more pieces to it. You have invested some money in a mutual fund. A mutual fund is a collection of stocks purchased by a mutual fund company. You can buy a portion of the collection, and you make or lose money based on the total return of all the stocks in the fund. While a real mutual fund is usually composed of dozens or even hundreds of stocks, let's say ours has 5. Each stock has a likelihood of earning or losing a certain amount of money over the coming year. The first stock has a 10% chance to make $1,000, but a 90% chance to lose $100. The next is 25% likely to gain $400 and 75% likely to gain only $100. The next has equal chances of gaining or losing $600. The fourth has a 60% chance of gaining $750 and a 40% chance of gaining $100. And the last stock is 20% likely to gain $2,500, but 80% likely to lose $250. So what is the expected value of this investment, taking into consideration all those probabilities and amounts? Well, to find the expected value, we simply multiply each probability by its corresponding amount, and then add it all together. For the first stock, we multiply 10%, or 0.1, by $1,000, and add it to 90%, or 0.9, multiplied by negative $100. It's negative because it's a loss. This gives us an expected value of a $10 gain. For the second stock, our calculation gives us a $175 expected value. For the third stock, the calculation shows that we have equal chances of gain or loss, and that results in an expected value of 0. The fourth stock's calculation gives us an $850 expected value. And finally, the last stock figures to an expected value of $300. So our total expected value for this mutual fund is $1,335. In this card game, we will win a prize based not on a single desired outcome, but on groups or combinations of outcomes. We are going to turn over 3 cards, one at a time, from a standard deck of 52 cards, and depending on whether we have 3 red, 2 red and 1 black and 2 red, or 3 black cards, we will win different prizes. As it turns out, there is more than one way to get these outcomes. From our deck, we turn over the first card. This card could be red or it could be black. Now we turn another over. Again, this second card could be red or black. Finally, we get the third card, again either red or black. Although we have 8 possible paths in our tree diagram, notice that if all we care about is the combination of how many reds and how many blacks, we can group some of the outcomes together. Here we find that we have grouped the 8 possible outcomes into 4 groups. one outcome of 3 red and no black, 3 outcomes of 2 red and 1 black, 3 outcomes of 1 red and 2 black, and 1 outcome of no red and 3 black. The probabilities of each group is therefore 1 out of 8 for all red and for all black, and 3 out of 8 for 2 red and a black, and for 1 red and 2 black. This kind of game can be analyzed using Pascal's triangle. Pascal's triangle is constructed in rows, with each row representing a trial in our sequence of events. In our card game, a trial is a draw of a card, and we end up on row 4 after 3 draws. In the first draw, we end up at row 2 with a possibility of 1 red or 1 black. In the second trial, ending at row 3, we could have 2 red, a black and a red and a black, or 2 black. Notice that the 2 groups of different cards can be combined into one group of 2 cards. In the third trial, ending in row 4, we have 4 possible outcomes as we saw earlier. The number of possible outcomes doubles with every row. Pascal's triangle is easy to construct if you remember the pattern. Notice that all rows begin and end with 1, and if you add adjacent numbers in any row, the sum gives you the number between them in the next row. For example, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5. As long as you can remember to start with 1 at the top and then 1 in the second row, the rest is easy.